reason at all. All right, so now probably the easiest way to tell if something's a function is the vertical line test. Okay. So if there's no way possible to draw a vertical line and cross your graph more than once, then you know you have a function. Yep, so if no vertical line can be drawn so that it intersects a graph more than once, then the graph is a function. Okay. Now, if it intersects the graph more than once, then it's not a function. So if the graph is intersected more than once, it is not a function. Okay, so we'll draw out about 4 quick examples. Say this is your x-axis and that's your y-axis. It's your x-axis and your y-axis. And draw 2 more. Okay, so we're going to have 4 different graphs. And you want to determine whether or not they're functions. Okay, so let's say for our first graph is just regular negative function, linear. Say this one, say this is y equals 5 or something like that. It could be y equals 5, y equals 4, y equals anything. Y equals -8. Doesn't matter. If y equals anything, it's just going to be a horizontal line. Okay. Say for this one, it's a circle, somewhat circle object. Okay. Say for this one, this is just a vertical line, x equals 3. Okay. Now here, if we just draw vertical lines, no matter where we draw a vertical line, it'll only cross that graph one time. Let me make that a little bit darker. Okay, so if you notice here, it only crosses the graph once. This vertical line only crosses once. So no matter where you draw a vertical line, it only crosses one time. Yep, so it is a function. Okay. Same thing here. Since this is our graph, no matter where we draw a vertical line, yep, it only crosses once. Okay, so you know this one's also a function. Okay.
Not a function.
Yep, so this one, same thing, not a function. Gotta give someone else a chance. Can't give the answer right away. Okay, so here, as soon as you draw a vertical line, it crosses twice. Okay, so you know this one's not a function.
This is a function.
Nope, this one's actually tricky.
It's not.
Yep, because it's not a function. Because if you draw a vertical line, it crosses that graph everywhere.
Oh, what?
Yep, so if you draw a vertical line right through it, it goes through the entire graph.
Oh, it's going to take all the left.
Yep, so it's not a function. So it's not a function. Since a vertical line will cross the graph everywhere. Let me kind of draw a imaginary vertical line.
What do we call this graphing? I forget. What do we call this graph?
What do you mean?
Like, you know the names of parallel. It's not like, it's not vertical.
Oh, parallel and perpendicular when you compare two of them.
Yeah.
Yeah. Okay. So any questions on that one? All right, let me leave that up there for a few more seconds. Everyone's still writing. Look like everyone's done. Okay, so we'll do two more quick examples. So if we have our x and our y, this graph is actually just your y equals x squared graph.
That's another example.
Yep. So before we did the example just with the equation, but this is just giving you a visual of the graph itself. Okay, so you know here, you draw a vertical line anywhere.
Well, it's not going to cross.
Yep, it's not going to cross more than once.
So it would be function.
Oh, brought that up a little too high. So it is a function. But if you remember, we had x equals y squared.
Okay, so
Oh, keep that down a little bit. I'll bring that over here. Now x equals y squared looks like that. This is x equals y squared. So remember, anything with a y squared is going to be a parabola turned sideways. And as soon as you draw that vertical line, draw it a little bit darker. There you go. It crosses twice. Yep. So you know it's not a function. Okay. Any questions on that one? All right, leave that up for a few seconds. Looks like everyone. Oh, still have some writing. All right. So now we're going to review function notation. Which is just where we change y equals f of x. Okay. So this is just a function of x. Or if you read it, it just reads as f of x. Okay. So literally you're just replacing y with f of x. So that means, let's say y equals 3x plus 2 becomes f of x equals 3x plus 2. That's the difference between function notation. Okay, so let's say, for example, if we want to find each function value. Okay, so for a, and the thing is, it doesn't have to always be f. It could be g of x, h of x, r of x, r of s. It could be any variable at all. But most popular one is f. But it could be f, so you can use any one. So let's say if g of x is equal to 3x minus 2. And we want to find g of 1 and g of 0. Okay. And let's say for problem B, if f of x equals 7x squared minus 3x plus 1, and we want to find f of 1 and f of negative 2. Okay. Now our solution for A, if we wanted to find g of 1, it literally just means replace every x with 1.
You replace all the x with 1?
Yep, you just replace every x with 1. So that's just going to be 3 times 1 minus 2. Clean that up a little bit. Okay, so that gives you 3 minus 2, which is 1. So that means g of 1 equals 1. Same thing with g of 0. You're just going to replace every x with 0. Okay, which is just 3 times 0 minus 2. just 0 minus 2, which gives you negative 2. Okay, so we know